Hello and welcome back to Mr. Powers Teaches Algebra. Let's do one more word problem for our section 2.3. And it is a mixing problem. So these kinds of problems, we're given these weird questions to say, hey, we got this percent concentration of a solution and this percent concentration. How much we add of this one to get this much of a this much percent solution type of thing. And so, without further ado, let's take a look at this. How much of a 50% alcohol solution should we mix with 10 gallons of a 35% solution to get a 40% solution? Okay. So, I'm kind of cheating here, but the gist of it is this. And this is real similar for even one of the problems we just did. I think the one I did for work. I said amount of work plus amount of work equals amount of work. So if you or even when I did the distance one here, distance plus distance equals distance. You know, it's kind of that same idea. So the way we want to think about it is the amount plus an amount equals an amount. And this is the way we're going to set it up. The amount of alcohol in a 50% solution. Well, because first, well, let's read the problem. Oh, we did read the problem. That's right. So how much of a 50% alcohol solution should we mix with 10 gallons of a 35% solution to get a 40% solution? So right away, this is what we have. We have an amount of alcohol. So it's going to be, amount of alcohol plus an amount of alcohol is going to give us an amount of alcohol. There you go. So that makes a lot of sense. Now, how do we find the amount of alcohol? Very similarly, like we had a formula here for amount of work. Work is rate times time. And we could solve for the rate to get work over time. That's our rate. You know, we can do things like that. We can do something similar here. We could say that the amount of alcohol is really the percent concentration. So let's say here, the amount equals the percent concentration times the amount of that percent concentration times we'll say the volume of that concentration. So the amount of alcohol, in this case, it could be the amount of a saline solution. It could be the amount of whatever. It's going to be that percent times the volume of the liquid we have. Okay, so this will make a lot of sense, I think, as we fill this in. Let's see here. Make myself a little room. That didn't quite work out the way I wanted. Okay, there we go. So we're going to slide that up. Good. And we're going to continue working on this problem. Oh, no, I didn't want all that in there. It's annoying. Okay. Knew it didn't look right. Anyway. Let's see here. So, the amount of alcohol in a 50% solution. Well, how much alcohol do we have in our 50% solution? Well, let's see here. So we have 50% solution. So that amount is going to be 0.5 because it's a 50% solution, or 0.5 times how much of it did we have? It says how much of a 50% alcohol solution should we mix with? So that actually we don't know. So let's just say that's X, because we don't know that. So X is our amount of a 50% solution. Okay. So then we're going to have a plus our amount of a 35% solution, right? So that's going to be 0.35 times, well, how much of that do we have? We have 10 gallons of a 35% solution. So times 10, because 10 gallons times 0.35, because 35% of it is alcohol. That will tell us the amount of alcohol. So that's where this fun thing comes in. There we go. Equals, and what do we want to get? We want to get a 40% solution. So we're wanting to get a 40% solution. So 0.4 times what? How much of that do we have? Well, we're adding X amount, or the X volume plus 10, X gallons plus 10 gallons. So it's going to be X plus 10 gallons. And that's the equation we get. So it is a very, these are a little bit trickier, but that's how we do it. And so now we can go ahead and solve this, and it's not really that bad at all. Let's see here. Okay. So what do we have? 0.35. You know what? I just don't like decimals. And so I am going to multiply everything. No, we can just distribute first. So what do I have? I have 0.5x plus 0.35 times 10 is 3.5 equals 0.4x plus 0.4 times 10 is 4. Okay. So now, again, I'm like, I don't want to deal with decimals. I'm going to multiply both sides by, let's see, what do I want to multiply both sides by? By 10. That's going to get rid of my decimal. So times 10 times 10. So 10 times 0.5x, now that's 5x, plus 10 times 3.5 is 35, equals 10 times 0.4x is 4x. 10 times 4 is 40. This is a much nicer equation to solve. And now I can worry about getting x by itself. I got x's on the right. I got x's on the left. So I'm just going to get rid of the ones on the right because there's less of them over there. That's really all I'm doing. So minus 4x. Because I don't want them there. I don't want them on both sides. Whatever I do to one side, I have to do to the other. And, you know, while I'm at it, I'm going to get rid of that 35 on the left. Because you can add and subtract at the same time. So, right here, that's gone. What do I have? 5x minus 4x. I have x on the left. So we have x equals, those canceled. I got 45 minus 35 is 5. Well, there you go. Too easy. Now, with any of these types of problems, the big deal is always, was it asking for x? And what was x again? Because honestly, I didn't really do a very good job. I mean, I said what it was, but I didn't write it down. X is our amount of a 50% solution. That's what X was. So anyway, it says, how much of a 50% alcohol solution should we mix? So yes, that is what it was asking for. So X, and we were in gallons. So we would say we need 5 gallons of a 50% alcohol solution to add to 10 gallons in order to get a 15-gallon solution of a 40% solution. And that would do the trick. You gotta love it. And so that's how you do these kinds of guys. So at the end of the day, again, it's not really that bad as long as you have this basic understanding that the amount that you're going to have of something is that percent concentration times its volume. And so we keep that in mind. These are really easy to set up. So until next time, enjoy doing math.